Now we're going to focus on cosmology. Cosmology is the branch of astronomy that specifically deals with the properties of the observable universe. According to the secular worldview of evolution, cosmology primarily focuses on the origin of the universe as described by the Big Bang. Let's revisit this question. What are stars? Stars are balls of plasma that radiate energy from inside themselves. They are self-bound by gravity, so stars are believed to begin with and form from a collapsing cloud of gas and dust, which is called a nebula. Now, the atoms inside the nebula are believed to accelerate inward due to the force of gravity, and when those atoms collide rapidly with each other, they're going to give off a tremendous amount of heat and temperature, and that's going to yield a young star. And a young star is called a protostar. So it's believed that in the nebula, the cloud of dust and gas, we have rapid spinning and acceleration of atoms. They hit with a strong force due to the gravity inside the nebula. That strong force then gives off a very hot, dense composition of matter, forming a star, specifically a proto or young star. This is basically the HR diagram of classifying stars, focusing on color with surface temperature, the size of the star, the composition of the star, and the brightness or luminosity of the star. So you maybe heard this in elementary school. The blue-white stars are going to be the hotter stars. Then as we move to the yellow, that's kind of in the middle, that's more of our sun, our star. And then red, usually seen in the red giants, are going to be the cooler stars. The sizes, we have dwarfs, we have giants, we have supergiants. So they can be medium sized, they can be very small or considered dwarf, or they can be gigantic. Then we have the composition, mostly hydrogen and helium. And then brightness or luminosity is just the amount of energy given off. And we talked about Henrietta Swan-Leavitt, who focused on luminosity of variable stars. Here's another diagram that kind of compares the size with temperature, luminosity, color. As we talk about luminosity and brightness, we're going to focus on magnitude. That is how much brightness is given off. So we have absolute magnitude, which is the real brightness of the star, how much light is really given off. And this is going to be compared to apparent magnitude. And apparent is just saying what it seems like. It could seem like it is brighter than really what it is. So apparent magnitude is focusing on how bright the star appears to be to us on Earth. Now the focus on how far stars are away from us is focused on light years. So basically the distance away from the Earth, we're going to measure that in light years. This is going to be the distance light will travel in a year. So we have very large numbers, how long it's going to take, 10 million billion meters or 6 trillion miles. The speed of light is 186,000 miles per second. And we talked about very briefly before about a parallax. The parallax is the apparent shift, what it seems like to us over a period of time. So if something's very far away, it's going to appear to move slower than what something is closer to us. So if something's closer to us, it'll seem that it's going to move faster. Something further away seems like it's going to move slower. So the closer the object, the more it will shift in the position of the sky. So we may think, oh, stars don't really move, but in reality, that shift seems like it's not happening, but it can happen because of the distance and how far away the star is. Again, what is a nebula? That's going to be the cloud, the dust that's in space. This cloud is made up of different gases and will give off different colors and patterns. So we're going to talk about some nebulae, which is more than one nebula, and you're going to have to know them by their pictures. So here's the first one. This is the Horsehead Nebula. See if you can kind of see that, where they're getting the name from. This is the Bubble Nebula. This is the Eagle Nebula. And you can kind of see the beak and the head is kind of pointing up to the top right. And the wings and body kind of spreads to the middle to left. Then we have the axis of evil. Looks like an evil eye. We have the Rose Nebula, or the Rosette Nebula. We have the Triangulum Emission Dirac Nebula. We have the Cat's Eye. We have the Red Rectangle. And then we have the Red Rectangle. Now there are two types of star clusters that you're going to need to know. There are galactic and globular. Galactic clusters are going to be open clusters. These are dozen, 2,000, and here's the focus, young stars. So because they're young stars or protostars, they may still be found in and around a nebula. They usually have spiral arms in their galaxy. Now, globular clusters are going to be not dozens to thousands, but millions to hundreds of millions of older stars. And they're going to be clumped closer together. This is going to be your red giants and your dwarf stars, but they're especially near the center of the cluster. So galactic or open, more spread out. Younger stars can still be found maybe near and in a nebula. Globular, they're closer together. There's more of them and they're older. Now let's identify what a supernova is. A supernova is a star explosion that gives off extreme brightness and heat. And then we're going to talk about some different galaxy shapes. And the galaxy is a system of billions or millions of stars filled with gas and dust that are held together by gravitational acceleration. These galaxies are found in different shapes, sizes, and classifications. We're only going to focus on a couple of them. But as we look at the structure of the galaxy, make sure you know the bulge, the disk, and you can see the globular clusters, the star clusters around the outside. There's a glow around the galaxy, and that's called the halo. Again, you can see the halo, the disk. So here are spiral galaxies. This is more of a circular pattern, a circular spin. It will have arms that branch off, kind of like a hurricane. This has lots of gas in younger stars. But the older stars are usually going to be either in the central bulges or in the halos, the halo, the glow. Then you have the Barge Spiral, which is a specific type of spiral. The Barge Spiral would be very similar to what we have in the Milky Way galaxy. Our own solar system is located in this type of Barge Spiral galaxy. And as we're talking about the Milky Way, there are 200 billion stars. We believe it's a Barge Spiral. There are 100,000 light years. It is believed to be 100,000 light years wide. Our sun is halfway to the edge. It is calculated and estimated that our solar system is going to take about 2 million years to revolve once around our galaxy. So the galaxy and what's inside the galaxy is believed to be moving. So this is an estimation of how long and how much, how large that galaxy is. Continuing on with the different galaxies, we have the elliptical, which is like an oval shape, kind of a football shape. And then we have lenticular. Think of a lentil bean. It's a small little circle, but there are no arms here. Then we have irregular galaxies, and there's a lot of different types of irregular galaxies. This is just no pattern, no shape. And then let's focus on what a black hole is, as well as black matter. And we don't have a lot of information. We're still researching a lot of this, but a black hole is basically focusing on uh, density. Basically, it's considered the densest object uh, from which not even light can escape. It's believed that the larger the galaxy, the more massive the black hole, and we don't know what which came first, the galaxy or the black hole. If the galaxy formed the black hole, what's happening? And regarding dark matter, we can't see it, but we do know it does have gravity. It's believed it's a component of the universe whose presence is basically identified by the gravitational attraction rather than the brightness. Because brightness focuses on what we can see, everything else, the dark matter, is what we can't see.